Before we begin, a disclaimer: this podcast is for informational and entertainment purposes only and should not be relied upon as the basis for any investment decision. Nothing you hear is an offer or solicitation to buy or sell any security. The securities discussed on this podcast may be owned by persons being interviewed. Before making any investment decision, please consult an investment advisor. This happened to be one of those times when our write-ups intersected on the same week. It doesn't.
Not planning for it, right?
Yeah, we didn't plan that out, and it usually doesn't happen.
Right.
So yeah, I thought maybe like a good place to start off would just be to discuss, just to walk through the basic design steps, and I can do that part first. So yeah, I can just kick that up. I will say, like, every time I write about anything semis or biotech related, my imposter syndrome radar goes blaring. So I've got to so I try to be careful in this write-up about checking all the details and making sure I wasn't making claims I hadn't earned the right to make.
I noticed that, when I was reading your earlier piece on Cadence and Synopsys, I think back in 2020, if I'm not mistaken.
Yeah.
And you mentioned right at the end of the write-up, hey, look, I'm just trying to learn this stuff. If something's wrong, let me know.
Right. So I can make that excuse the first time. And the second write-up, I've got 5 years later, I've got to maybe take some ownership over some of the things I write. So yeah, I try to be careful. Nevertheless, I'm sure, I'm off on something. So, I mean, kind of bear that in mind.
Yeah, these are very, very technical stuff. One thing that I just want to add in the beginning of this conversation, I think 4 years ago, let's say around 2020, 2021, I think I would be more skeptical of my ability to kind of, get up to speed on a technical company like Cadence or Synopsys within a few weeks. Thanks to ChatGPT or all these, numerous chat bots that's out there. I think it definitely accelerated the pace at which you can kind of get up to speed. Especially when it comes to super technical stuff like biotech and semiconductors. Obviously, you can get up to speed doesn't mean that you will gain any expertise, and you can still be off because it's so easy to fool yourself that you know what you're talking about. Just because you have asked some questions and get some answers. But yeah, it's still kind of eye-opening to me that I remember, I think 3 or 4 years ago, I actually mentioned explicitly that one of the reasons I try to avoid semiconductors is basically just the technical nature of it and how difficult it is to kind of get up to speed really, really quickly. I think that fear has, I would say, largely dissipated thanks to this, chat bots. Obviously, like you were saying, I'm still viscerally aware of the difficulty of really getting to the nitty-gritty, detailed technical stuff. One of the concerns that I always have that even with these chatbots, yes, now I can get to the, let's say, table stakes of knowledge a lot faster. But obviously, investing is always about the future, right? Where things are going, where things are heading. I still feel somewhat uncomfortable when it comes to that. How comfortable I am to realize that, I get where things are today, but how comfortable I am or confident I can be in seeing the future, where things get a little hazy, little less comfortable, even with these chatbots, right? So that's just a disclaimer I wanted to give.
I think I made a similar point in my Marave write-up where I said, I can kind of basically understand how, the capping process works, but there's a huge difference between that and then being able to think 3 or 4 steps out because you've got deep industry expertise. That's always the problem as a generalist. You can learn about this very narrow area of the domain, but you don't know what you don't know about all the things surrounding that domain that are very closely adjacent. And that's where the risks may appear, and you can just kind of be blind to that. And so it's it can be tricky for sure. So I thought, having said all that, so the design process, so basically, you've got the front end and the back end. And Cadence and Synopsys, they provide tools for both of those sides. So on the front end, basically, you start with a description of what you want the chip to do, how the logic operations transform the data at different states. And so you express that in a high level language like Verilog or VDHL at what's called the register transfer level. Or that code then goes through a rigorous testing process called functional verification, where you're testing to make sure that the design works exactly as you intended. So if you tell the CPU to add 2 and 2, it should return 4 under a wide range of stress conditions. And functional verification, it's considered the most onerous and time-intensive step. Yeah. I was told it takes up to about 40% of the total chip design time, and that's if you're using hardware emulators. And if you're not, it could take up to like 60% of the time. And so, but it's a super important step though, because the idea is you want to catch as many errors as you can before moving further downstream where the changes are harder to make. And so, so once you've gone through functional verification, and then the high level code is turned into lower level logic functions that the machine can understand. And that's called logic synthesis. Okay. And the output of logic synthesis is what's called a net list. And that basically details all the cells and how they're connected to one another. And so that's front end there, at a high level. The back end, I think of that as converting the front end's abstract representations into actual geometry that you can visualize. Okay, so the back end, it starts with floor planning, where you're taking the CPU cores and the memory blocks and other components, and you're laying them out on a die. And you want to think of this as like a high level blueprint. And so once you've got that, then the fine-grained details are filled in during a process called place and route, where you're arranging the logic gates, the registers, the wirings, the buffers to reduce latency and power and make sure all the signals get to where they need to go at exactly the right time. And that's more of an iterative process. And so after place and route, you then move into what's called the sign-off stage. And that's basically where you're testing that, all the signals are free of interference and noise, that there aren't any unwanted electrical effects, that the data gets to where it needs to be at the right time, that the physical design is compatible with the fab's manufacturing rules, and that the layout that you have is identical to the net list that was synthesized earlier. And so after you've done that sign-off phase, so you've almost got, like, if you think front end, back end, you've almost got two subparts of those where it's like design and then testing. So you're designing stuff, and then you're making sure things run right.
Right.
At both of those stages. And so after sign off, the finalized layer is then sent to the fab, and the fab uses that to make photomasks used in lithography. And so
fabs such as TSMC, like the Global Foundries, Intels of the world.
Exactly. Yeah. And so I drew an analogy to city in my write-up. So I thought just maybe a way to drive what's going on home in a more understandable way. I just quote kind of what I wrote in the write-up.
No, I like that analogy. So please go ahead.
Yeah, cool. Okay, so returning to the earlier city analogy, the front end of chip design is like planning a city, defining zoning guidelines, permitted activities and structures, and specifying how buildings should connect to the roads and utilities. The back end, by contrast, is akin to actual construction. Floor planning maps out where major roads, districts, and buildings should go, while place and route fills in the fine details, laying down the building components, wiring up the network cables, installing power lines, and coordinating traffic lights. Finally, the sign-off process resembles the work of a city inspector, certifying that all the streets and utilities and structures meet regulations and faithfully match the original plans. If this is a city, it is an extremely centrally planned one, where every building, sidewalk, and power line is specified in advance, and every person is expected to show up at a designated place at exactly the right time.
Hey, central planning works.
Exactly. I don't get what all this fuss about capitalism is Yeah.
No, no, no. No, I actually liked, so I was reading your piece, yesterday, and there are a couple of things that really stood out when, like, just when you were just talking about the basics. So, the couple of things like, so one thing you mentioned, like the digital chip design. So they're like obviously analog chips and digital chips, and
Hmm.
digital chips are actually 4 to 5 times larger. So I knew that, digital chip design is a lot larger, but it was helpful to see it quantified that it's 4 to 5 times larger. Uh, and I'm pretty sure we'll get into more details about Cadence versus Synopsys. Cadence is like much more dominant in analog chip design, and
Yeah.
Synopsys is more competitive in digital chip design. And you kind of already touched on it, but I also just wanted to quickly mention because I thought this was very helpful for me to kind of conceptualize the importance of the verification stage. Like I know, like verification is super important, but I think the way you kind of put it was helpful. So I just wanted to quickly mention. So you touched on it, a little earlier. So you said it is also widely considered the verification. It is widely considered the most time-intensive step, often consuming up to 40% of chip development time. And here's the important part that really was helpful for me. Of the 40 or 50 tools used from design start to finish, 10 are concentrated here. In fact, functional verification is so resource intensive that it's often treated as its own distinct category within chip design. As in there's verification and there's everything else, and the number of engineers working on everything else is like a third of the number working on verification. I thought that was very
Yeah.
helpful to kind of conceptualize how important that is. And, Synopsys is basically much more over-indexed to verification and the tools that requires in verification. So that kind of helped me kind of appreciate Synopsys' position within that kind of, space.
Yeah, that's right. And so I was also and that piece of knowledge came to me when I was talking to a former engineer at Synopsys who had worked on functional verification specifically. And I was saying, my understanding is there's front end, back end. He's like, no, no, no. There's functional verification
And
and
everything
there's
else.
like implementation. Yeah, and he divided it into like verification and implementation. And he said in this implementation bucket, it's everything besides
Hmm.
functional verification. But yeah, his basic point to me was like there really is a certain special emphasis on this step because of its time intensive nature and just the fact that you really have to get you really have to make sure that the logic is right before sort of moving on to the physical layout.
Yeah. So, speaking of like, synopsis, so I kind of, looked in a much more, did a deep dive on synopsis. I spent more time on understanding their history, and how it kind of came out to be, than let's say like Cadence. So I just want to kind of, as I was kind of going through their history, it's interesting. Synopsys was actually part of General Electric, GE, and like back in mid 1980s, I think there was some semiconductor downturn. GE got cold feet, like they wanted to spin it out, and they're still kind of like a little startup within GE. So uh, they actually took the technology. They even got like some funding from GE, and kind of went out on their own. So the chip designers like back then were used to managing that like entire chip designing task manually, like drawing out circuits gate by gate. And this was obviously a very laborious process, and it could take like
Mhm.
weeks or months to for any complex circuit, with like frequent redrafts and like cut and paste edits done by literal like scissors and tape. So it's a very manual process. And obviously, like, Synopsys thought there's probably a better way to do it. And what's interesting is like, when you think about that in the context of Moore's law, so Moore's law was obviously like, it's not like, a law, it's an observation, right? By Gordon Moore in the mid 1960s that transistor density is basically doubling every, 24 months. And so by the time Synopsys was basically founded, and interestingly, it was founded, I think, 3 months after TSMC. right? So a lot of interesting companies were basically being founded around the same time.
Yeah.
And so by the time Synopsys and TSMCs were founded, it's been already like 2 decades after Gordon Moore made that observation that transistor density is basically doubling every couple of years. So if you just played around like for 20 years, that observation, like if you are in the industry, you could probably kind of see that what's coming. Like, hey, the way we are designing things, like with like hand drawing, manual stuff, this will like completely crumble. This is not going to work. Like, if you just fast forward, if you think, Moore's law, obviously people are predicting Moore's death of Moore's law for forever, right? So probably there are people out there back then who are like, hey, this is not going to work. How are you going to do it? We are all doing this manually. And if this like, transistor density just keeps, going up, it's not going to work. We are not going to be able to design chips in a way that respects or keeps Moore's law intact. Obviously, people have always been found multiple ways to kind of, figure out things. And Moore's law is still kind of going on, right? Obviously, it has slowed. Transistor density is not really doubling every 18 to 24 months. Those days are gone, but still it's continuing. And this ingenuity, not just like, I think one thing that probably a lot of people miss, like, obviously it's a complete value chain, semiconductor value chain. And there are like so many innovations that can pop up in different parts of the value chain, which can really help that like, Moore's law, the observation kind of, keep going. So, the design tools, ADAs, were kind of an incredible innovation back then that they made you free from this manual design system and use this incredible design automation tools, which really like, people are skeptical in the beginning, but I think like, so they went out and become like independent company in like mid 1980s. And by early 1990s, pretty much all the semiconductor chip design companies were like Synopsys customers. So it didn't take too long for people to realize this is the future. Clearly, this is the much better way to do this. So yeah, like, and I saw like a picture of like, chip designing, like, a diagram, and it's like so incredibly complicated. Like you just take a look at it and you realize there's no way we're designing this by hand. We need some software here, right? So yeah, like, in some sense, if you are in the industry, you could see like there's got to be a new tool here. There's got to be a new industry here. There's no way we're going to be able to keep up with Moore's law if you are, going to design things by hand, right? So that's how it kind of started. And Cadence and Synopsys, now they're a duopoly. They weren't a duopoly, obviously, from the get-go. It took like multiple decades to kind of come to that natural end state, I would say. So yeah, so that's kind of a like fun little history I kind of noticed when I was kind of studying the early years of Synopsys. I didn't do that for Cadence. I don't know exactly what are the
Yeah, I have
similarities
a
and
few
dissimilarities.
details on Cadence. It's
Okay,
okay, so Synopsys, you were saying they're not spun out of GE, but it was founded by a team of people from GE, I guess.
right.
And then Cadence, that was a merger between ECAD and SDA, and then they later acquired Valid Logic, and so that was like the core. And then for Mentor, okay, so like in the early days of EDA, there was this company called Daisy Systems, and I don't know if they were the leading player, but they were certainly like one of the primary, one of the dominant players in the early days. And Daisy merged with this company, Cadnetics in 1988, and the combined company went bankrupt,
Okay.
basically. Yeah, so like Daisy Systems was kind of they were having problems before they even merged with Cadnetics. I think what was going on is they had a like a workstation that they were trying to vertically integrate with the software, but you had other powerful Unix workstations that were more generalized that people were using at the time. And so there was that unbundling of hardware and software that was going on back then that Daisy Systems didn't really adapt to. And so that caused them a lot of problems and eventually led to their demise. And so then Intergraph acquired the bankrupt assets. And then Intergraph spun off all the EDA assets, and those assets were then bought by Mentor, and then Mentor was acquired by Siemens in
Yeah, yeah,
2017 for like 4 billion, 4.5 billion or something. And so,
right.
so now like, and there's been a ton of acquisitions, obviously, like since then.
Yeah.
But essentially, where we stand is, I think Synopsys and Cadence each have a roughly 35% share.
Uh-huh.
Um, and then Mentor, it's hard to say, but I've heard like 15% around there. So yeah, it's a fairly consolidated space, and really, when people talk about this industry, they're pretty much talking about Synopsys and Cadence. They're kind of the Visa and Mastercard.
Right.
Um, yeah,
Yeah, no, I think that's a apt analogy. Like, just as Visa and Mastercard, uh, there are like similarities. Like Cadence and Synopsys are basically 1 to 2% of uh, semiconductors industry's revenue, right?
mm,
So Visa and Master, but also they are like mission critical. Like, without
right,
Cadence and Synopsys, you can't really imagine the rest of the value chain, right?
yeah,
Similarly, obviously, Visa and Mastercard are like very mission critical for basically the base layer of capitalism at this point, right? So,
yeah,
so without Visa and Mastercard, things look pretty dire.
yeah,
So yeah, so it's just a much for Visa and Mastercard, it's a much wider, grander canvas versus, let's say, Cadence and Synopsys, but at the same time, the semiconductor itself is like the base layer of, I don't know, innovation, economy, like, technology, right? So yeah, like, these are pretty incredibly important companies that
yeah,
not many people know about unless you are in investing or like you're following semiconductor industry. But like, I didn't know much about this industry. Like, I haven't heard about this company, I would say 5 years ago. Right. And now it's like, obviously still not super like, widely talked about, but also, I think, it's just more, like generally people are more aware that it's not in the semiconductor industry the entire value chain, like each part of the value chain is like dominated by one or two companies, like either duopoly or oligopoly, sometimes just monopoly, like TSMC, right? The advanced nodes. So I think this just is generally increasing the more awareness, uh,
yeah.
the critical role the entire value chain plays, not just like one single part of the value chain. And obviously, everybody and their grandmother has heard about NVIDIA, right? So,
Yeah.
yeah,
And
can you go ahead?
and yeah, it is funny. Like when you look across like the semiconductor value chain, it's like at every juncture you've got an oligopoly or a
Yeah,
monopoly,
yeah.
essentially. Yeah, and then you've got EDA tools, as you were saying. I mean, the mystery here has always been they're absolutely essential to holding up the industry, but they're a few percent of industry revenue.
Yeah, yeah, no, I mean, it's also interesting to note that they spend a lot of money, for if you are like a stable duopoly, if you think you have reached the natural end state, you don't really expect to see 35% of your revenue being spent on R&D year in, year out, not just like, and it's not even
Right.
declining, like, oh, there's maybe some scale benefit over time. No, there's no scale benefit. It's been going on for like last 10 years or so. 30 to 35% of the revenue is being spent on R&D. So that's something obviously interesting. But
Yeah.
I guess it would be kind of interesting to just clarify again, like why complexity leads to more EDA revenue, and like how obviously chip designing itself is getting more complicated by the day, right? And
Yeah.
why that's good news for companies like Cadence and Synopsys.
Yeah, I feel like this is going to be a bit of a long rant,
Sure.
so
Go
bear
for
with me
it.
here. So, all right,
Yeah.
let me. So, I guess the place to start here is like there's two concepts worth understanding. There's Moore's law, and then there's Dennard scaling. And Moore's law,
Right.
everyone's kind of familiar with.
Mm.
That's just transistor density doubling every 2 years. And then Dennard scaling, that essentially means, power density stays constant as transistors get smaller. So like
Hmm.
your power per transistor goes down, but you're fitting more transistors into a given area at smaller and smaller nodes. And so power density over that area is kind of unchanged. So basically, every 2 years for the longest time, you were getting chips that were faster and more power efficient, right? But it just so happens that, if you go below a certain transistor size, that relationship starts to break down and you run into problems. You get more current leakage, more heat. The signals don't go where they need to go on time. And so there were a few innovations that emerged to address those issues. And the first was like transistor innovations. So starting around, say, 2011, we went from 2D planar transistors to FinFETs, and then around 2022, we started seeing mass production of gate-all-around transistors. You could read my write-up for more details about that. I won't go into it here, but basically the thing you need to know is that the way transistors work is you've got electrons that are flowing from one side of the channel to another side, and then there's a gate that controls that flow.
Yeah.
But when transistors get too small, that gate doesn't work as well in controlling the flow, and you get some leakage. And what FinFET and gate-all-around do is they essentially just allow for better control of that channel. Okay, so that's at the transistor level. Then the second innovation is around chip packaging. So in a traditional 2D setup, you're putting, the logic piece, the memory, the I/O components alongside each other on the silicon die. And, that runs into issues at a certain point because, to tie those parts together, you need longer interconnects. Interconnects, you can just think of those as like wires that carry signals to different components. They're not exactly wires, but that's conceptually the idea. And that creates like greater resistance because you're traveling these longer distances, more latency. You're also using bigger chips, which results in a lower yield because a bigger die increases the chances that you run into an error. And so with 3D architecture, the idea is instead of building out, you're building up. Okay, so you break the logic and the memory functions up into smaller chips called chiplets. And then you stack those chiplets on top of each other and you connect them with interconnects. So you'll see that design in like high bandwidth memory. So like NVIDIA's Blackwell uses high bandwidth memory, and that HBM, it's like a tower of like 8 memory dies, right? That are kind of stacked. And so these innovations important, but they come with trade-offs. The basic thing to understand from a chip design standpoint is the more elements you add in order to get around these performance and power constraints. So with FinFET, you're adding fins. With GAA, you're adding like these nanosheets. With 3D packaging, you've got like TSVs. With 2.5D packaging, you're adding this interposer layer. And the more elements that you add, the more failure modes you create. Okay, so with 3D and with 3D packaging, you've got this added challenge where because you're stacking chips, you're trapping heat and you're creating hotspots in that stack. And so first of all, what that means is you're creating a lot more interactions between more parameters that need to be tested over more combinations of values. And so you're doing a lot more testing, more iterations, right? And the tie from from that to EDA revenue is this. So like the EDA revenue model, it's not like most software models that we're familiar with. So if you think about a company that has 100 employees, buys 100 annual subscriptions to Microsoft Office, then each of those 100 employees can use Office as many times as they want in a year, right? Yep. So the number of licenses exactly matches the number of employees. There's a one-to-one relationship. With EDA, you don't have that one-to-one between user and license. So instead, what happens is a design firm, they'll have like a fixed pool of licenses that designers can draw on, and each active job will consume a license. So if your designs are getting more complicated, you need to run more jobs, do more tests, and you're running all this stuff in parallel. That's a crucial point, right? You need to run these tests in parallel because it'll take prohibitively long to do these tests serially. And so you're running more tests at the same time, and therefore you're using up more licenses. And so that's the way complexity sort of translates to EDA revenue. But then also, this isn't exactly related, but I guess I should mention it. So with 3D packaging, you have to start thinking of a chip less as a chip and more as a system, right? And you're running into like thermal and mechanical issues that need to be simulated. And so now you have, like
multi-physics
OEM
problem. right?
Yeah, that's right. Yeah, I think you know where I'm going with this. And then you've got like OEMs and hyperscalers who are also designing their own like custom ASICs, and they need to think about chip design considerations in the
Yep.
context of the overall system that's part of. And this kind of like, to your point, gets into why Cadence and Synopsys have been, acquiring their way into simulation software that can model the mechanical and thermal and electrical relationships.
So after I read your piece, I think, one thing that was clear to me. So I was kind of, curious to know that it was actually Cadence
Yeah,
who wanted to acquire Ansys. And then Ansys basically, I think, shopped around. Mentor Graphics also wanted to acquire them, but eventually it was Synopsys which basically gave them like a acquisition offer. Obviously, it's still not approved yet by regulators. I think UK and EU kind of approved it. US hasn't really said anything. Looks like it's going to be approved by the US regulators as well. The big question is obviously China. Like, who knows
yeah,
what they're going to do? My guess is, you know, uh, it can create a lot of tension if they don't and everybody does. I don't know how Synopsys or Ansys will react to that. It may actually go down to White House and like who knows, and then what happens. I actually read that. So when I read that, I was like, okay, it's interesting that Cadence was more interested first about Ansys. And then when I read your piece, I realized I kind of drew the connection that actually Cadence would not be able to buy Ansys, even if they tried, even if Ansys, and I think Ansys probably realized that and they thought, you know what, we would love to be acquired, we want to be acquired, but probably not by Cadence, but because Cadence is not going to get their regulatory approval. So what I like, just reading your piece, I realized Cadence bought like a bunch of like tuck-in acquisitions in like
yeah,
simulation space, right? In the last 4 years. I think the number you mentioned, they spent like $1.9 billion in like last 4 years, which is like 85% of their total M&A deployment. So kind of, substantial, right? Like not like, not immaterial. I wouldn't call it substantial, but like not immaterial. And if this company even goes on and buy like the biggest of them, like 800-pound gorilla in like simulation space, which is Ansys, if Synopsys has difficulty buying Ansys, imagine what Cadence would go through if they wanted to buy actually Ansys, right? So my
yeah,
guess is, Ansys realized that, okay, it would be great to be acquired. Like it makes sense for us to be part of like a greater EDA design IP company because our simulation stuff can be more like a streamlined, like one unified data model and like a single workflow. So it all makes sense and where things are going, as you were kind of alluding. So I think Ansys realized that it would be great to be part of one of either of these two companies, and I think their call was, yeah, Cadence might be interested, but actually they're not going to be able to buy us. And our best bet is to get acquired by Synopsys. Obviously, that's not a sure bet, 100% bet that they would be able to acquire Ansys, but I think that was their best bet. Like, obviously, I think it doesn't make a lot of sense to be part of Mentor Graphics, which is not like a does not have a great presence in design IP or EDA space in general. Like they're like 15% market share, I think. Like distant third player, also ran company within like Siemens, right?
yeah,
So yeah, it was always going to be either Cadence or Synopsys, and I think the reason Synopsys kind of won out in that kind of tussle is because Ansys realized that maybe it wouldn't make sense to go with Cadence anyway. And I know just hearing you talk about how complexity is increasing and how that is kind of leading to EDA revenue and how you have to run these jobs like in parallel and it's not necessarily tied to your seats. Sounds like they may be more immune from like the concerns around AI disruption, like a lot of people talk about when it comes to enterprise software, like, oh, if these agents are basically doing the jobs and it's not like the employees, then if you are like a seat-based subscription model business, there might be a bit of a challenge for you to kind of capture your value. But that doesn't seem to be a concern for a company like Cadence or Synopsys. Do you
Well, it
agree
could
with that?
cut the other way though.
Okay.
If AI gets so efficient that you need fewer licenses. So AI as a growth driver is pretty obvious, right? Like we're just getting more computational. We just have more computational needs, and the intensity is just going up every year, and that's a nice tailwind for Cadence Synopsys for the reasons we talked about. But then the second thing to consider is just how Cadence and Synopsys are using AI tools and how AI sort of changes the competitive landscape a bit, maybe a little bit. So I mean, Synopsys and Cadence use AI in basically like three ways. So like first is like it can be used to predict how design stages made at one stage will affect, you know, KPIs downstream. And then the second way it's used is it's used to narrow the search space. And so you've got like all these different parameters that can take on all these different values. And rather than systematically testing all those combinations, the AI can pick out, you know, the few hundred most relevant ones to test. Right. And then the third way, and this is the most kind of frontier application is AI agents, where you've got, you know, an agent that works to optimize RTL, another agent that optimizes place and route, another one for floor planning. And then you even have another agent that checks the work of the other of all the other ones and orchestrates this all together and takes the human out of the loop. And I think, and the way I think this was Synopsys. I can't remember which one made this analogy, but they analogized this to like autonomous driving, and they said, you know, we're essentially at the equivalent of the L1, L2 stage right now, where engineers can direct these agents to make recommendations or to generate RTL within like a narrowly bounded, you know, domain space, and with humans closely watching the work. And then, but at L5, and so L5 would just be the, you know, full autonomy, where you have all these specialized agents that are autonomously collaborating to produce the design. And so that's so we're pretty far off from that. Is the idea. So yeah, but then there's also, I guess, a possible competitive angle to this with news that Alphabet or DeepMind trained AlphaChip, right?
Yeah.
And so AlphaChip, you know, it's an open source tool and it uses reinforcement learning for the floor planning stage. And so I guess, you know, the argument I made, and look, this is such a...
Just to be clear, floor planning is basically just one step of the, at the back end of the chip designing stage, right?
Yeah, it's one out of, who knows, like a dozen or more steps. So yeah, and it's it's just one step. I spoke to an engineer who said it was people were using it a bit in place and route as well. So maybe it's going to be applied. And I think we maybe have to make the assumption that, you know, it's not going to stop where it is here and just going to keep getting better and be applied to more stuff. But like the so that presents, you know, a possible competitive opening. But the way, you know, this has been described to me is that the way you want to think about AI is it's an intelligence layer on top of the tools, on top of the algorithms. It's not a replacement entirely. And so you're going to be you might use AlphaChip, but you'll use that in conjunction with Synopsys or Cadence's floor planning tools. Like there's the tool level, and then there's like this other layer on top of it. And also Synopsys and Cadence, they have all this stuff weaved into their tools as well. And so there's a version of AlphaChip already embedded in their tool set. And so yeah, and so it's not like an existential type risk, but I think where things could get tricky is you know, if AI gets so good that and it optimizes things so much that you don't need to use as many licenses as before, and then and Cadence and Synopsys, they might then price for that, right? They'll say, okay, you're using fewer price, but it's more valuable, so we're gonna. But they may not be able to do that if there's like an AlphaChip alternative to that intelligence piece that they're trying to upsell. You know what I mean? So if the competition sort of moves to the AI layer, and you've got fewer licenses, so you can't sort of offset the fewer licenses with pricing. I think that could be a potential issue.
No, I think that's a very interesting point, and I think it's also important to note that how much the kind of revenue mix of these companies like Cadence and Synopsys has evolved. Like back in 2010, uh, pretty much all of Synopsys revenue, for example, was from semiconductor companies.
Right.
And today, for it's basically only 55%, and the rest of the revenue comes from what they call system companies. And system companies are, companies like Google, Meta, Amazon, Microsoft, Tesla, right? Which are not really in a, semiconductor business, right? That's not their like, primary business. They have like a different end market, but they just want more vertical integration,
Yeah.
and they have the scale and necessity to go for that sort of like vertical integration for their own product differentiation, right? And so yeah, like
Yeah, it's
maybe
commoditizing the complement, right? Basically.
yes,
Yeah.
yes, that's one of the favorite strategic sort of response for most of these tech companies, right? So, uh, so yeah, like I think that so that's why I think the kind of competitive vector may not come from the next like EDA tool company, right? In a startup EDA tool company, right? Or I'm somewhat like for example, obviously China is trying to develop their own homegrown like EDA, like design IP tool companies, but like without the geopolitical stuff, there wouldn't be one, right? They're
Yeah.
kind of forcing, and even then they're having difficulty. And it's kind of funny, like when I was looking at some of these, Chinese EDA companies, I think their largest was called Empyrean. Uh, yeah, Empyrean. And it has like 1% of Synopsys revenue, but their enterprise value is like 15% of Synopsys. Like Cadence and Synopsys, they trade at rich multiples, right?
Yes.
And you're saying that basically Cadence and Synopsys look like deep value investments if you look at like Chinese EDA companies. Yeah, they're
Yeah.
trading at like 58 times revenue multiple, right? So,
Yeah.
so yeah. So, anyways, without like the geopolitical pressure, I don't think there would be any competitive pressure from, let's say, these Chinese EDA companies.
Yeah.
But to your point, maybe that's the wrong framework. Like, if you think about obviously, and this is a key point, like this may not be relevant in like 2 years, 3 years, 5 years time frame, but obviously if you think about like 10, 20-year time frame, which is what I think you have to care about in you know, a company like, if you're investing in a company like Cadence Synopsys, especially given the multiple you are paying. So you better be right about
Yeah.
the competitive advantage that these companies will have over the next 10, 20 years, not necessarily 3 to 5 years, right? So I think, one of the things that I always, wonder about when it comes to this big tech, like if your big tech is your, like some of the biggest customers you have, the reality is some of these big tech companies, may not be all of them, but at least probably a couple of them will probably have, I don't know, like $1 trillion revenue, like in, I
Mhm.
don't know, 5, 10 years down the line, right? And obviously that's an enormous scale. If they see that someone is milking them and they have the capacity to kind of uh, like put their own weight behind that, like solving that problem, right? Things can get challenging for
Yeah.
those
That's
companies.
right. Yeah, and I
Uh,
think it's just worth noting that it is an oligopoly. These companies generate huge margins. They've got a lot of share, um, but it's still like very competitive between the two of them,
mhm.
Cadence and Synopsys. And I think when you think about EDA tools, it's easy to conclude that these have like software modes. When people think about software modes, they're thinking in large part about switching costs. So like an SAP or an AppFolio where
Yeah.
it would just be too big a pain in the ass to switch to something else, even though that something else is better. That's not how it works in EDA at all. Like yes, there are some switching costs in terms of just tool familiarity and whatnot, but in chip design, it all boils down to performance. Full
Yeah.
stop. It's like if there's a new place and route tool, out there that's unambiguously better, that's
Mm.
unambiguously the best. NVIDIA is not going to say, you know what? I'm going to stick with this inferior tool from Cadence because it's just too much of a
Right.
hassle to switch. Like that will never happen, right? And so
True.
you have to start thinking about the technical moats behind these
Yep.
companies.
Yep.
It's not good enough to say, oh, there's it's just switching costs and tool familiarity. It's the fact that like it would just be very hard to match the tools from a technical point of view.
Right.
And I was talking earlier about the former Synopsys employee who I had a conversation with, and he was saying, the algorithms underlying these tools are some of the most sophisticated you've seen on the planet. Like they've been trained over like tens and thousands of designs over decades across many different nodes, and so it doesn't sound like something you can just replicate by throwing money at the problem, right? It just takes there's a lot of iteration cycles and tweaking over years. And so, and even if this were just about the money, Cadence and Synopsys have spent like $30 billion
Yeah.
over the last
Yeah.
decade in R&D and M&A. And so it's just
Yeah.
an enormous investment. But all that doesn't mean that this isn't a competitive industry. It just means the competition tends to be confined between these like two established incumbents. They compete very vigorously with each other. It's not a sleepy oligopoly. There's intense benchmarking bake-offs with every new process node that they have to go through. And most of these large firms will mix and match tools from both companies.
Yep.
They
Yep.
go best of breed for each of these stages. And so, and some I learned even use licenses from both companies for the same step in the workflow, just to make sure they're getting like the
The best
maximum.
performance. Yeah. Yeah.
Yeah. And
No, it
so
makes
it's,
sense. I think
yeah,
what you are saying is also kind of reflected in numbers. Like today, Cadence and Synopsys, they have good, they have good margins. They have very respectable margins. So Synopsys is basically posting what, like mid 20s, low 20s margins, which are great, but which is fine, but not like eye-popping margins, right? Like, for a software company, like, where you have like 80-90% gross margin business, like, and have a stable like industry structure, like you have reached your natural endpoints, you'd imagine that, you might have like larger margins than in a low to mid 20s. But at the same time, like Synopsys had like mid-teens margins, right? Not so long ago. So as you know, and it kind of what it implies what you were kind of saying.
and I will also say like those margins, they don't, they to me, people may disagree with me on this, but I think that those margins are inflated because they don't take into account like the acquisition. You almost have to treat some part of acquisitions as like an R&D expense almost, because and look, the lines between growth and maintenance R&D kind of blur in this industry. And the same is true of like acquisitions here, because like these acquisitions, they're being made to pursue new adjacencies a bit, but also just to remain on the bleeding edge. They have to just keep making these. And it reminded me of like the Glengarry Ross scene, where it's like,
Yeah.
first place is a Cadillac, second place is a set of knives, and third place is you're fired, right? You really can't afford to be like, the third or fourth best player. You need to be in the frontier at like every node just to stay competitive. And
Uh-huh.
so, yeah, what you'll see with both these companies, that they're making acquisitions all the time, every year.
Yeah. So I was
And
actually mentioning about, I know, like Cadence and Synopsys both, when they talk about margins, they mention the most inflated, most like convenient sort of margins, non-GAAP operating margins, where they add back all sorts of stuff. I was actually talking about operating margins, so I am taking into
yeah,
the amortization and all that. Like,
but
I'm
there's also goodwill. There's also goodwill that isn't being
that
expensed.
okay, that's true. That's
Um,
true. Yeah.
and
So
so,
yeah, like, that kind of supports the point you were making earlier, right? Like, if it were so like, uh, super moty, as kind of end state of the competitive differentiation, like, just, obviously when you reach there, you're supposed to make gobs of margins, right? And it's not quite there yet. And I think one of the quotes that I came across, it was kind of interesting. I think Cadence's CFO was asked about R&D's spend, and he mentioned like half of the R&D dollars basically goes to uh, growth, R&D for tools or like softwares that don't generate any revenue yet. So you can just think about them as like pure
Hmm.
like growth R&D. But he also mentioned something like, obviously, as long as Moore's law is kind of continuing and they have to kind of keep up with the technology or innovation, and as long as that continues, they have to spend
Yeah.
this like elevated R&D dollars. But the interesting thing that he kind of alluded to is like, if Moore's law kind of, let's say, uh, slows drastically, right? Uh, then he was mentioning like, R&D dollars can go down to even 5%, right? And margins can go, obviously, if that goes, margins become like super high. He was alluding that the revenue growth will slow down, right? And he was basically saying, you know what, we're agnostic whether the, Moore's law continues or like, slows down drastically, because if it continues, we're going to spend the hell out of our R&D and we'll stay at the bleeding edge, right? And if
Yeah.
it like, Moore's law kind of disappears over time, that also fine. We don't have to then spend like 35% of our revenue on R&D. We can probably spend like 5-10%, and we can go to like, 50-60% operating margin business, right? Uh, Obviously, the question that I kind of, wonder about, and I don't have any clear answer, is basically what the ripple effects are. Like, as you were kind of talking about,
Mm.
if the innovation slows down and you have this $1 trillion revenue big tech companies, right?
Yeah.
They can say, why are you paying 60% margin to this, like, companies? There is not a lot of innovation going on in this industry. Let's spend some money here for like few years and, get up to speed, and then, or at least just for the sake of, ensuring that they don't like, keep increasing prices every year, right?
Yeah.
So yeah, I don't know like what the ripple effects are. Like, my guess is the CFO, the way he was kind of describing those scenarios, it felt a little little too static to me. Like
Mm.
everything's static around him. He's just
Yeah.
changing variables in his spreadsheets, right? I'm not sure whether how static everything around him will be if that becomes a reality, that Moore's law is not really an ongoing phenomenon in like 10-20 years.
In that kind of world, there are other like ramifications on their top line, I would guess,
Yeah,
at that point. And so, yeah. And
yeah. So it's always hard to know those details. I'm skeptical about how simplistic he made it sound. But
mhm.
it's a point taken that they're spending so much dollars because they have to stay at the bleeding edge, right?
Yeah.
And although it's TBD, but like I think it's totally understandable that the R&D intensity will go down massively if no such requirement exists, in like in the long term. So we're
Yeah.
talking a lot about EDA, tools. They also have this IP business, right? It's probably 10-15% for Cadence. It's not as important, but it's actually important for
Yeah.
Cadence. For them, it's like 30%.
For
Uh,
Synopsys,
Synops,
yeah.
yeah, 30% of sales
Yeah.
for Synopsys, and it's interesting. Like Synopsys also had this software integrity business that they sold last year, I think. Yeah. Uh, if you go back and listen to their 2019 Investor Day, it's funny because software integrity was such a huge focus for them.
Right. Yeah.
Yeah, yeah.
Yeah.
I
Yeah.
was I was just laughing when I was listening to it because like I know now that they sold this business, right?
Right. Right.
uh, I think there's probably a more cynical way to look at Synopsys's willingness to acquire answers. So the fact that it feels like Cadence was earlier in that trend that to
Yeah.
realize that simulation is going to be important, right?
Yeah.
And that's why they did like bunch of these acquisitions, and now obviously Synopsys is kind of following them. going for the
Yeah.
jugular, right? I mean, they are paying $35 billion to do this deal, and who knows if it's going to go through. Uh,
Yeah.
Imagine a scenario that they instead of going for this like niches in the software integrity like business unit, they also do this like sort of like simulation tools. Maybe they would be in a better position today than kind of going for a detour and then coming back to the realization that, oh, we need simulation, right?
Yeah.
Cadence is kind of getting ahead of us on that front. So like but I think investors were more annoyed and after a
Mhm.
few years, like people probably thought that software this business would be high growth and higher margin. It was just
Right.
not panning out. It was actually a drag for
It was
their
direct.
margins.
Yeah.
Yeah.
It was very
So
dilute. I think it was like
yeah,
15% type margins, or
yeah,
something. I don't know. Yeah.
yeah.
It was very low though. Yeah.
Yeah, yeah. Who knows? Maybe they needed more time to kind of, get to a certain scale to get a higher margin. But anyways, that bygones be bygones. It's not part of the business anymore, so let's not talk about that. But yeah, IP is still like a big part of Synopsys' business, 30% of their revenue. Uh, but it's also like a bit lower gross margin business. But on and from a, I don't know, EBITDA, adjusted EBITDA, like the kind of a uh, embellished version that they talk about. From that perspective, that both the IP business and the EDA business have similar adjusted EBITDA margin, 38, 39%.
Hmm.
So kind of similar, but the gross margin is lower for the IP business. And it's basically the IP is basically the reusable design blocks that chip designers license rather than develop from scratch. And
Right.
you can think of it as like a prefabricated parts for chip design. And they have like three different like categories of like IP, foundation IP, processor IP, and interface IP. And Synopsys is more into foundation and interface. Processor IP is basically it's where ARM kind of thrives.
Yeah.
So yeah, foundation IP basically are like essential building blocks like memory compilers, standard cell libraries, basic like analog components that form like the backbone of any basically chip design. And interface IP provides the standardized communication protocols like USB. Basically, 90% of USB protocols basically come from Synopsys, so they're like super dominant in that space. There's this growing trend of 3P like IP design taking more share because it's for a lot of the chip designing companies, it doesn't make a lot of sense to spend a lot of engineering effort to do the things that's already available in the 3P market, which you can buy.
Yeah.
Uh, so yeah, that's why it's
Yeah.
growing. Yeah,
And
and
I always compare it. I kind of think about it in my mind like the IP blocks. They're kind of like the plumbing and electrical parts in a house. They're very
yeah,
important, but they're not differentiated across houses, right? And so
absolutely.
like no architect needs or whatever. No designer has like a comparative advantage designing those kind of parts on their own. And
Right.
so yeah, yeah,
Yeah. So that's basically at this point, like both these companies have become more uh, like a pure play in EDA and IP, but obviously simulation is also coming to the equation. It's been interesting to see how Synopsys reports or incorporates and ANSYS into. They have pretty lofty goals when it comes to this ANSYS, integration. Like they are looking for like $400 million revenue synergy and cost synergy by year three. So that's like $800 million. Uh,
yeah,
I'm always somewhat skeptical about revenue synergies, uh, but cost synergy. You know what? I feel like it's doable because back in 2014, 15, maybe even 5 years ago, not even that long, ANSYS used to have like 35% margin. Now they're like,
mm,
yeah, I think 2014, 2015, they had like 37% margin. And now they have like 26, 27%. So there's like a material like contraction in margin. So they're looking for $400 million cost synergy, which is basically 25% of ANSYS's cost base. OPEX base. So not, not, I think that's kind of substantial. At my first glance, I was
Yeah.
like a bit skeptical, but then when I kind of looked back, I'm like, okay, this business used to be like 35, 37% operating margin business. Now it's like 25, 27%. So maybe there's room. Both these companies, probably Cadence as well, they have become very, very voracious in doling out stock-based compensation. So, if you can, check those, maybe it's possible to get a lot of those cost synergy at least. Who knows what's going to be for the revenue
So what
synergies?
is I don't know if you have this
Yeah.
is figures on you, but is stock-based compensation as a percent of revenue, do you have like how that's trended over the years, over
Yeah.
time for
Yeah,
Synopsys?
so like 10 years ago, this used to be for both. I don't remember Cadence off the top of my head, but both Ansys and Synopsys, back in like 2013, 2014, they used to be like 3.5% of their revenue.
Hmm.
Today, it's like 11% of their revenue,
Hmm.
right?
Yeah.
And the funny thing is, like, if you look at Synopsys, for example, I think they spent like, I don't know, like $6 billion or something, like almost like a significant percentage of their free cash flow in buying back shares.
Hmm.
Like significant. I don't remember. I don't want to say the number because who knows, I could be wrong, but it's pretty material. 6 billion, right? And their diluted shares outstanding is basically flat, right? Because the stocks have gone so up, like obviously they issued at like a low price. Now the stock have like much like 3, 4, 5x, right? Over the course of like last 10 years, it's probably 5,
Uh,
7, 8x. So now when they're buying back those shares, you know,
yeah. Hey,
it takes a lot.
sell low, buy high. That's the key.
Right. So it takes just a lot more money to reduce their share count. Uh, but yeah, like, I'm always kind of, too careful not to spend too much time on stock-based compensation because the reality is, yes. So I think, I see like two complaints from people when it comes whenever I talk about stock-based compensation. One is like, look, if the stock doesn't work, it's not going to be because of stock-based compensation. Now,
Hmm.
that's true if you're like going to be around for 1, 2, 3 year period, right? And it's also true over even for 15, 20 year period. The questions of like, the competitive differentiation, the Moore's law, like, China, like those are going to be much bigger driver. I get it.
Yeah.
I agree. I understand, right? But at the same time, like there's a difference between like getting 8% IRR versus 11% IRR,
Right.
right? And ultimately, that's probably all your alpha, right?
Yeah.
Like if the market gives you like 8% IRR, right? And you invest in, let's say, Cadence or Synopsys and you get 8% IRR, let's say you match the market, right? Uh, but if these companies probably were not as generous in, paying stock-based compensation, maybe you could get like 10% IRR, 11% IRR. And that 200, 300 basis points of like, return is substantial over the course of
Yeah.
20-year period, 30-year period. I think a lot of people miss that, like because people obviously most of our careers, 20 years is like such a long time. We will not be around probably to see for most people, right? So they don't care about that. But obviously it matters, like in a long time frame, the compounding nature of this, compensation, it really makes a huge deal. So yeah, but I agree it's not like, if you lose money here, it's not going to be because of stock-based compensation, right? That's not going to be the driver. But the difference between 8% IRR, 11% IRR, you are still doing okay in both scenarios. But in one scenario, you could do a lot better. That's what I'm
Yeah.
saying.
Um, and I also think like, I mean, I think Cadence is the more expensive one, right? That's
Yeah.
in the 50 times range. I think if you strip out the stock-based comp
Yeah.
on this year's earnings, yeah, it's easy to be bullish on these companies, at least just on sort of the fundamentals alone, like
Right.
just the big moats and then the growth drivers. So just to break down like what I think the growth drivers are, it's the number of design starts, it's the growth in complexity, which leads to the license growth.
Yep.
It's And then also like on the IP side, so like if as we get more into like 3D packaging, you're using chiplets, and so you need to replicate some of those foundational IPs across each
Yes.
of those chiplets, right? So you're creating more demand there, and then also the compute demands are creating this wider gap between the number of cores on a chip and the speed at which data is fed into those cores, and so the interface IP needs to get more sophisticated, and that drives higher, ASPs theoretically. And so it's just, and I mean, look, I hear this AI thing is going to be big one day. I don't know. That seems like kind of a risky, out of consensus call, right?
Very out of
Yeah,
consensus. Yeah.
right.
Yeah. David,
So
you're
anyway,
so contrarian.
yeah, it's very easy to see how just all the growth drivers are there, the moats kind of there, and they're expecting like they've kind of grown revenue sort of like low teens over
Yeah.
the last whatever 5 years or so. So going from like a pre chat GPT world to now where we are now, they've grown at like a low teens type of rate, and they're essentially expecting more of the same going
Yeah.
forward, just like low teens.
Hmm.
Extrapolate that out. You really need that to to happen,
Yeah,
right?
no, I
If
can
you're
I can
buying
kind
at
of
these multiples here.
give you kind of a quick math.
Yeah.
So first, I obviously have did a model for Synopsys, and I can just talk about that. So for Synopsys, if you are looking for, let's say, 10% IRR, uh, the kind of quick and dirty math is you need 12% revenue growth. If you assume 12% revenue growth for the next, let's just 7 years or so, and you assume 600 basis points of operating margin expansion. So like right now they're like at 23%. So let's say 29, 28,
Hmm.
29% over the course of the next 6, 7 years. And then you assume 40 times terminal PE multiple, you get 10% IRR, right?
Yeah.
So so to me,
And Synopsys is the
there's a
cheaper
cheaper
one,
one.
right? Yeah.
I'll say though,
Um,
I know people talk about how Cadence is more expensive than
mhm,
Synopsys, uh, but the reality is Cadence consistently had like higher ROIC. So they
mhm,
had in the last like 6 years, they have consistently posted 25 to 30% ROIC, whereas
yeah.
Synopsys did better in the last 3 years, but like in I don't know in 2018 to 2017, 2019 period, I think they had like high single digit ROIC. Now it's like
Mm,
high teens. So obviously
mm,
it got better, and obviously incremental ROIC is probably super important. But at the same time, I think the consistency that Cadence has shown over a longer
mhm,
period, and like it's consistently 25-30% ROIC, you are in the same industry, and it looks like Cadence was probably seeing the ball a bit more clearly when it comes to where to position yourself, and they didn't have to detour with like a software integrity business. All that factor, to me, I feel like I don't feel strongly about why Synopsys needs should trade at similar multiple at Cadence. To me,
yeah.
kind of makes sense why Cadence is trading a
Mm,
little bit higher, uh, multiple. So to me, like I'm not, I don't have an opinion,
yeah.
or I don't feel strongly that just because Cadence is trading at a higher multiple, it's like actually more expensive. Like it
Right.
looks
Right.
expensive. I don't know whether it actually is more expensive, will prove to be more expensive over time. But yeah, like probably my guess is
Mhm,
I haven't done the math for Cadence, but my guess is that probably the math is similar. So
yeah.
that's what when I look at the number and mind it, these companies are like going through 25 to 30% drawdown. So the numbers I'm talking about, it is after they experience 25 to 30% drawdown, right? So I was just looking at the math, I'm like, okay, there's very little margin of safety here. So I need like the growth persistence to be there. And then we need 600 basis points operating margin expansion, which you know, may not be super easy. Like we're kind of talking about in this podcast, like, how there is a bit of like a competitive intensity. It's not like, kind of a lazy industry here, right?
Mhm,
Where you can just, increase margins and you don't have to worry about anything else, right? So there is
yeah.
a competitive intensity, kind of sneaky competitive intensity in a way. So you are expecting, despite that, you are expecting 600 basis points of margin expansion. And then you need 40 times terminal P multiple, which can be fine, but you have to, yeah, like, it has to be the case that 7 years, 8 years down the line, when we are in 2031, 2032, we will sit there thinking we're still feeling pretty good about Cadence
Yeah,
and Synopsys'
that's
future.
right.
Only then we'll
Yeah.
have 40 times kind of, P multiple. So maybe it can happen. It can happen, right? But to me, it felt like it's probably like a top quintile scenario and not
Mm,
necessarily like a base case scenario, right?
mm.
So it can still
Yeah.
happen, but I just didn't feel a lot of margin of safety there.
Yeah. Yeah. I think we probably both arrived at the same kind of place as far as just these as investments go.
I think, to me, the more interesting question for, like, if you think about like buying these stocks, uh, can usually appear when there's like a, let's say, sustained drawdown. So the
Hmm.
question I always kind of, struggle with, like, for example, let's say it comes back to a valuation where I'm comfortable with, like, okay, I can see 10% IRR and I have some margin of safety. But the reality is when you will find this stocks at that valuation, it's probably the case that the whole market is kind of going through a drawdown, and there's like all these other opportunities. Then you have to choose something like that for like 10% IRR, probably at a higher duration versus, let's say,
Yeah.
something that's going through like a more pronounced drawdown, but may not have that sort of like visibility in the very long term, like 10, 15 years period, right? So
Okay. I think that's all I had.
yes,
Is there anything
we'll we'll come
else we
come
should?
back with another overvalued stock next month.